Welcome to the Artificial Intelligence course, a complete introduction. I'm called Long. Today, I will present to you the first lesson in the machine learning module of this course. As you have learned from the previous lesson, machine learning is a branch of artificial intelligence and is perhaps the most important AI subject today. Now, let's start exploring this very interesting topic. As a matter of fact, along with AI, machine learning is one of the most recognized terms in the world of technologies today, and people are talking a lot about it. So, what exactly is machine learning? Before answering this question, let's start with a motivation example: spam email filtering. I think that most of you are using at least one email application, for example, Google Mail or Yahoo Mail. If you look at your email application, you will find a folder called Spam, and we know that all potential spam emails are moved here automatically. Concretely, if an incoming email is likely to be a spam, it is moved to the spamming box. Otherwise, it can stay in the reception box. That sounds simple, but the underlying application always had to deal with the question: how to know if an email is likely to be a spam? Here is an example of a spam email, and I think that many of you have seen many similar emails like this. Let's have a look at this body. Your email address was selected to claim the sum of $500,000 in the 2011 European lottery. To claim your prize, please contact our agent in Lagos, Nigeria. That sounds stupid, but sometimes it works. And in order to avoid that kind of emails, we need a good filtering strategy. Normally, such kind of spam emails can be recognized based on some patterns in their content. For example, some popular patterns may include discount, offer, free, or congratulations, you win something, or click here to get something extra. Imagine that you are asked to develop an application that filters spam emails. What would you do? Here is a very classically simple solution. It's just an example, but I would like to show you the idea of a simple solution without AI nor machine learning. Let's have a look at this pseudocode. We want to compute the probability that the email is spam. So we first initialize this probability as 0. Then, for each word in the email's content, we do a check as follows. If the word is discount, then we increment the probability of spam by, let's say, 20%, for example. If it is offer, we increment the probability by 30%, and so on. In general, we prepare a list of spam patterns. Then, we compare each word in the email's content to each pattern in the list. Finally, we decide that the email is a spam if the probability of spam is greater than a constant, let's say 70% for example. So, this is a very basic idea of a simple spam filter. However, if we filter spam emails based on this kind of solution, we have to manually update the pattern list whenever the spammers modify a pattern. For example, the word for you can be varied as for you with the word you replaced by the letter U, or they can use the number 4 instead of the word for, or a combination of the two. And if it is the case, what we could do in our simple solution is to update the pattern list, for example, adding some variations for each pattern in the list. And we have to repeat this action each time the spammers modify or create new patterns. It's really a daunting task. So we can say that this kind of simple solution cannot work effectively. Indeed, what we really need in this situation is an intelligent mechanism that can automatically learn spam patterns. With this idea, we don't have to deal with manually specifying spam patterns. And to design such a mechanism, machine learning is a great choice. Now, as you already see the motivation of machine learning, I would like to give you its definition. According to Arthur Samuel, machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. If some of you may get confused of what is without being explicitly programmed, then you can refer to the previous example about spam filtering. Whenever spam patterns change, we have to update the code to deal with new patterns. But in machine learning, the application must be able to learn new patterns without having to be reprogrammed. Indeed, this definition by Arthur Samuel is considered as an old definition of machine learning. In academic context, people prefer to use a more formal definition by Tom Mitchell. A computer program is said to learn from experience E with respect to some class of task T and performance measure P. If its performance at task in T as measured by P improves with experience E. For simplicity, you just need to remember the three words ETP, which stand for experience, task, and performance. Tasks are some objectives or some goals to achieve. Experience is knowledge or useful information. And performance is the quality of the output. Consider our previous example about spam email filtering. Indeed, the problem can be stated as the following. Given a set of emails that were already classified as spam or not spam, this is called the training set, which may have, let's say, 1,000, 10,000 or 100,000 emails depending on your capacity, but the more the better. Then, for any new incoming email, the system must be able to determine if it is a spam email or not. In this situation, the task T can be considered as detecting spam emails. Okay? The performance P is the rate of correct decisions. And the experience E can be considered as the set of previously classified emails or the training set. And you should know that this kind of problem is called supervised learning, that is, learning from labeled data, or in particular, emails that were already classified. In fact, there is also unsupervised learning, that is, learning from unlabeled data. So, are there how many types of machine learning and what are they? These questions will be answered in the next lesson.